In a game similar to Call of Duty, a mortar shoots a bomb and hits a target at the distance of 870 meters. What is the maximum height? So the question is about this height here. The maximum height of the bomb during the flight, and what its velocity. The velocity at the highest level will be horizontal, because at the highest level, at the moment when it is the highest level, it's not anymore flying up, and it's not yet falling down, so it's flying horizontally. The angle between the barrel and the ground, so that's this angle, alpha equals 60 degrees. Ignore the difference of the ground height between the mortar and the target and the aerodynamic drag. This means that the height of this point is exactly the same as the height of this point, so the entire trajectory is ideally symmetrical. The clue, the main point to solve any kind of a problem similar to this is to decompose the initial velocity, and never mind that we don't know the initial velocity, we probably will at some moment, okay? One essential thing about solving physical problems is when you start this problem, don't worry about any values that you don't know, okay? You don't know velocity? Never mind, okay? You don't know time? Never mind. Some of you asked me in your test papers, how can I find velocity without knowing time? I will demonstrate in a moment that it's quite easy. Just try to use the formulas that you have as the weapon, okay? And try to go forward, try to find out as much of these values as possible. So one thing that we can easily find, this alpha angle appears also here. This is the velocity, so we can quite immediately find the formulas. This is Vx, the horizontal component of the velocity, and this is Vy, the vertical component of the velocity. Both components can be immediately found. So Vx is nothing else but V multiplied by Vx. Is it sine or cosine? It's a adjacent side. V is hypotenuse, so it's apparently cosine. V cosine alpha, and cosine alpha, cosine of 60 degrees, according to what is given in this exercise, is 0.5. So Vx is 0.5 V. V is the initial velocity, the main velocity, this one. Similarly, vertical velocity is V sine alpha, which means it is 0.87 V, according again to the values provided in the text of this exercise. Okay, so we have some very important for the beginning. And now they are asking us about the height, so we should know something about the profile of this vertical flight. It's like throwing things up, so it's going up, decelerating, stopping, then falling down. If we just would know this initial velocity, okay, and time, alright, we know the gravitational acceleration, we will know everything, but we don't know velocity, we don't know time. But it won't prevent me from actually writing the formulas. Formulas are something I can always write, I can always know something about them. One of the main formulas here will be about this vertical velocity. Vertical velocity, okay, is given by a formula gt. In this exercise, everything shows that this is the surface of the Earth, and actually the exercise tells gravitational acceleration g equals 10 meters per square second. So we know g, we don't know t, we don't know vy. But we know that Vy is 0.87V. So 0.87V equals GT. And nothing particularly more that I can find here. I could actually say 10T because I know the G value. So it's 0.087V equals T. Okay? But I don't know V, I don't know T. I have two unknown in a single equation. I need something more. Definitely I need something more. What can I find more? I can say something about the horizontal velocity. As you should know, in ballistics, this horizontal velocity is not accelerated. It's a constant speed. It wouldn't be constant if there were any aerodynamic drag, but the text of this exercise clearly specifies ignore aerodynamic drag. So it will not change this velocity. Vx is 0.5. And we have the distance. And this distance, x, equals vt, velocity times time, are not two important things. First of all, velocity, it's x velocity, it's horizontal velocity component, so that's this one. And time, while it flies this way, it's the time, one time when the bullet, not the bullet, it's a cannonball or bomb, if it is shot by a mortar, it's called a bomb. This bomb is going up for the time t and then going down for the time t. So if t is a single time of going up or going down, we need here double time. Okay? So we have x equals 2vxt. So x, the distance is 870. This equals 2 times vx, the horizontal component of velocity. It's 0.5v, multiplied by time. 2 times 0.5, it's 1. So we get 870 equals Vt. And now we have two formulas. One is here, the other is here. Two simple formulas, two unknowns. We can with two unknowns and two formulas, we can find the two unknowns. This is already solved against t, so I will try to do exactly the same thing here. So t, from this formula, t equals 870 over v. And this thing, I have t equals this and t equals this, so I can use both formulas to have something like this. So I'm replacing t here with this value here. What I get is 0.087v equals this thing, 870 over v. And now I have one formula. This is equation mark. I will make it pretty. This is a single formula, one unknown, so it's not particularly difficult to find the value of this x. I will multiply both sides by v, so I get 0.087v squared equals 870. So v squared equals 870 divided by 0.087. This is 870 divided by 8.7, it will be 100 divided by 0.87. 0, 1, it will be 10,000. Okay? If you have any difficulty with this calculation, use a calculator. If v square is 10,000, then we can immediately, I'm run out of space here, let me put a big line here, okay. So v is square root of 10,000, it's 100. So quite easily we got the velocity. Now we know that x velocity is 0.5 times v, so times 100. It's 50, and that's the first of the answers that we have to find. This is the horizontal velocity, so that's the velocity at the highest point, 50 meters per second. The vertical velocity is 0.87 times 100, so it's 87. They are asking us about the height. Height is just the distance traveled in accelerated motion. The first phase is decelerated motion, which is maybe a little bit more tricky, but remember that this entire flight is ideally symmetrical, so the second phase is just falling down from the height of h. So h, according to a widely known formula, is g, because g is our acceleration, gt square over 2. Oops, we don't know t, but t can be taken, for example, I think it may be taken from this formula. So it's g is 10, okay, times t squared. T is 870 over v. V is 100. And this is squared divided by 2. And I will use my pre-calculated value of the height. If I can only find it, it's 378. That's simply 870 over 10, it's 8.7. Finding the square of 8.7 may be a little bit tricky, but you can use, just to ensure that this result is visible, so use the calculator and you will find out that this maximal height is 378. So the answer is the height is 378, and the only component of the velocity that the bomb has at its highest point is 50. Thank you.